Okay, so this is lesson 2 in unit 4. The lesson is called Graphing Quadratics in Standard Form. Okay, so just real quick, recall that the standard form from lesson 1, the standard form of a quadratic function is f of x equals ax squared plus bx plus c. Now the next lesson is going to involve graphing quadratics in a different form. Okay, if it's in this form, this is called standard form. So we're going to do 4 examples of these today. And for all of these examples, we're going to follow these 5 steps. So I'll read through them quickly. You can pause the video if you want, or you can just read the document on Classroom or Canvas that has this. Okay. First, find the axis of symmetry. That's step 1. And the axis of symmetry comes from this formula. X equals opposite of b divided by 2a. Then step 2 is find the vertex. You get the vertex by substituting the x value from step 1 into the equation of the parabola to find the y value of the vertex. Okay. Step 3 is find the y-intercept. You get that by replacing the x's with 0 and solving for y. And then step 4 is try to find some additional points. And you want to make sure your graph should contain at least 5 points to look really good. And then finally, step 5, connect your points and then move on. Okay, so here's the graph of a parabola. We did this yesterday in that lesson, but there's the parabola right there. There's the axis of symmetry. These are called the x-intercepts. That's the y-intercept, and that's the vertex. Okay. So like I said, we have 4 examples today. Okay, example 1, graph f of x equals x squared minus 2x minus 3. I want you to fill in these 5 things. Okay, so let's start with the axis of symmetry down here. The formula for this is x equals opposite of b divided by 2a. You always use that formula. So b is negative 2. Opposite of negative 2 is positive 2. Divided by 2 times a is 1 because 1x squared. So divided by 2 times 1. So 2 divided by 2 is 1. X equals 1. That's the axis of symmetry. So let's label that. And then let's graph it as we go. Now the axis of symmetry is not actually part of the graph. I'm just using that to help us graph the actual parabola. So I'm going to do a dashed vertical line at x equals 1. That's what I'm doing. A dashed vertical line at x equals 1. Now again, that is not actually part of our graph. Okay? But now let's get the vertex. So to get the vertex, I am just going to copy down the function above. So it was f of x equals x squared minus 2x minus 3. And to get the vertex, you are going to substitute 1 in for x, because that's what we got from step 1. So I'm going to do f of 1 equals 1 squared minus 2 times 1 minus 3. I am replacing the x with whatever we got when we did the axis of symmetry. That's going to be f of 1 equals 1 minus 2 minus 3. That gives me negative 4. Which means my vertex is 1, negative 4. Okay, so that's the x value of the vertex, and that's the y value of the vertex. So 1, negative 4. I'm just going to put that up here. And let's graph that. Now the y-intercept, I put that next. The y-intercept is whatever you get when you replace the x's with zeros. So you'd have 0 squared minus 2 times 0 minus 3. The quick way, it's whatever that number is. Okay, that's always the y-intercept when it's in standard form. So 0, negative 3. Now, I'm going to reflect that across the axis of symmetry. So think back to geometry. If this is 1 unit to the left of the axis of symmetry, then I'm going to reflect it, and I'm going to go 1 unit to the right of the axis of symmetry for that point. Okay, and now, okay, so first of all, maximum or minimum, okay, you can see the graph is opening up. Whenever it's a positive x squared, it always opens up. If it's a negative x squared, it means it opens down. But anyway, this graph is opening up, which means we have a minimum. And remember, the minimum always equals the y value of the vertex. So minimum equals negative 4. Well, I said I want at least 5 points on your graph, so let's get some additional points. Okay, so let's try to be smart about this. Let's try to pick an x value that we know is going to fit on the graph. So you don't want to pick x equals 0 because you already have that point. That would not be smart to do. You don't want to pick x equals 1 because you already have that point. Okay? You don't want to pick x equals 2 because you already have that point. You don't want to pick x equals 10 because it's probably not going to fit on the graph. Okay? Try to pick something around this area. So how about we pick x equals 3? So I'm going to say let x equal 3. And we're going to substitute that into the original function. So this is the original function we were given in the problem. I'm just recopying that down here. And I'm going to substitute 3 in for x. So I'll do 3 squared minus 2 times 3 minus 3. And you just have to be careful and make sure you follow the order of operations. 3 squared is 9. Minus 2 times 3 will be minus 6, and then minus 3. 9 minus 6 minus 3 gives me 0. That means I have the additional point 3, 0. So I'll graph that. And I'll reflect that across the axis of symmetry. So if this point is 2 units to the right of the axis of symmetry, then I'm going to go 2 units to the left of the axis of symmetry and plot another point. So I'll list that under my additional points. I'll put negative 1, 0 and 3, 0. But looks like we're good to go. We got 5 points. I said that was good to have. So draw your parabola, and that's it. Okay. Again, these are U-shaped, not V-shaped. Just be careful for that. And that looks good to me. So we're going to follow the same steps for all of these. So I'll go a little faster as we move through them. But I have 3 more examples. So this one has fractions, though. Oh boy. Here we go. Same process. Axis of symmetry first. Always do the axis of symmetry first, then the vertex. Axis symmetry, the formula or the equation is x equals negative b divided by 2a, or x equals opposite of b. Opposite of b, opposite of negative 2 is positive 2. Divided by 2 times a. A is negative 1/2. That means we have x equals 2. Divided by 2 times negative 1/2 is negative 1. So 2 divided by negative 1 means x equals negative 2. That's my axis of symmetry. I'll fill that in the table up here. Let's graph it. Let's always graph it as we go, okay? Because it comes in handy when it comes to reflecting. Okay, Next up will be the vertex. So let me just copy down the original problem. And let's substitute the x value that we got from the axis of symmetry into the vertex formula. So f of -2 equals -1/2 times -2 squared minus 2 times -2 plus 1. Order of operations, exponents, -2 squared is 4. So we have -1/2 times 4. Okay? You got to do the exponents first. Okay? And now you can do -1/2 times 4. That's -2. Minus 2 times -4, that's plus 4. And then the plus 1. That gives you 3. So that means our vertex is -2, 3. Let's fill in the table. And then let's graph that. Now the y-intercept is when you substitute 0 in for x. So again, the shortcut is whatever that number is. So 0, 1. And let's graph that. And let's reflect that. That is 2 units to the right of the axis of symmetry. So I'm going to go 2 units to the left of the axis of symmetry and plot a point right there. Now let's get an additional point. Okay. Now let's think about this logically. Okay. You want to pick something around this region. I'm going to pick x equals 2. The reason why I'm going to do that is because if I pick x equals 1, I'm going to get a fraction, and I'm going to try to avoid the fractions. So I'll do x equals 2. So if I recopy the original problem, let's replace x with 2. -1/2 times 2 squared minus 2 times 2 plus 1. Order of operations, exponents next. So 2 squared is 4. All right, so -1/2 times 4, I said, minus 2 times 2 plus 1. -1/2 times 4 is -2. Minus 2 times 2 will be -4 plus 1. -2 minus 4 is -6, plus 1 is -5. That means my additional point that I got was 2, -5. So right there, that is 4 units to the right. 1, 2, 3, 4 to the right of the axis of symmetry. So go 4 to the left of the axis of symmetry and plot that point. Now for the additional points, I'll put those down for additional points. So that was a -6, -5. And then we got 2, -5. You know, you may have different additional points if you were to do it on your own. But let's also do the maximum or minimum. It's a maximum this time because it's the highest point. And the maximum equals the y value of the vertex, which is 3. Okay, 2 more. Again, I'll go a little faster because now we've done 2 already. Axis of symmetry first. So that's our problem right there. You can pause the video if you want to. Axis of symmetry is always x equals opposite of b divided by 2a. Always that formula right there. So opposite of b means take the opposite sign of b above. So negative 2. Divided by 2 times a. In this case, above, a is 1/3. So 2 times 1/3. So that gives me negative 2 divided by 2/3. Oh boy. So think about that as being multiplied by the reciprocal. X equals negative 2 times 3/2. So it gives you negative 6 over 2, which means the axis of symmetry is x equals negative 3. That was a little tricky because you had fractions involved. Let's graph that.
Please pardon this interruption. Tennis practice today has been canceled again at courts of 2 left. If you are taking a bus home, please make sure you're on it. Thank you.
Okay, so that's my axis of symmetry. Now let's get the vertex. So we're going to substitute the axis of symmetry that we just got, that x value, into the original problem. So let me copy down the original problem right here. Again, I'll try to go a little faster because we've done 2 already. But replace the x with negative 3. Okay. Negative 3 squared is 9. Order of operations. Exponents first. 1/3 times 3 is 3. Minus 6 plus 5. So that gives me 2. So again, the vertex will therefore be negative 3, comma 2. Let's fill in this table. Negative 3, 2. Let's graph that. Side note, this is positive for A. A is positive, so this graph is going to open up. The y-intercept is that point right there. So 0, comma 5. Let's graph that. And then let's reflect that across the axis of symmetry. So when you reflect that across the axis of symmetry, it brings you right there. And by doing that, we can see we have a minimum, and the minimum value is always the y value of the vertex. So the minimum value equals 2. Okay, now let's think logically about our next additional point, because I want you to try to get 5 points, if possible. Maybe all 5 don't fit on the graph. Okay, I am going to pick x equals 3, because I'm trying to pick x values that I know will give me integer answers. I don't want any fractions. So if I pick x equals 3, this is what's going to happen, okay? Let me just recopy down the original problem again. F of x equals 1/3 x squared plus 2x plus 5. And let's substitute 3 in for x. So I'm going to have f of 3 equals 1/3 times 3 squared plus 2 times 3 plus 5. Just simplify that using the order of operations. So exponents next. 3 squared is 9. And now there's going to be no more fractions because 1/3 times 9 gives you 3. Plus 6 plus 5. So that gives me 14. So no big deal, that's okay. So my additional point is 3, comma 14. So again, that's not going to fit on my graph, but I'm just going to estimate. I'm going to go up there. I'll say that's 14. And if I reflect that, that is 6 units to the right of the axis of symmetry. So if I go 6 units to the left of the axis of symmetry, it brings me like right there. Okay, so that's negative 914 and 314. So I'll go with that. That'll be my graph. Okay, one more. If you stay with me through all this, shout out to you. Okay, so here we go. Same process. Axis of symmetry first. X equals opposite of b divided by 2a. I'll go a little faster this time because it's the last example and we've done a bunch already. X equals opposite of b, meaning negative 6. Divided by 2 times a, which is negative 3 above. So we have negative 6 divided by negative 6, which means the axis of symmetry is going to be x equals 1. So let's fill in the table and let's graph it as we go. X equals 1. Vertical line at x equals 1. Again, it's not part of the graph, but I just like to do it to help me reflect later. That's also why I'm doing it in a different color anyway as well, but not important right now. Vertex. I'll copy down the original problem again. F of x equals negative 3 x squared plus 6x plus 5. You have to be careful when you follow the order of operations, though, okay? So f of x equals negative 3. We're going to replace the x with 1 because that was our axis of symmetry. And again, this is not negative 3 times negative 3 is 9. That's not that. You have to do 1 squared first. Order of operations. So 1 squared is 1. So it's negative 3 times 1 plus 6 times 1 plus 5. So it's negative 3 plus 6 plus 5. I guess I can put f of 1 in each step. So negative 3 times 1 is negative 3 plus 6 plus 5. That gives me 8. So again, my vertex is 1, 8. Label that and graph it. The y-intercept is that number, so 5. 1, 2, 3, 4, 5. Reflect that across the axis of symmetry, and it brings you right there. Let's label that. This one has a maximum because the graph is opening down, and the maximum is always the y value of the vertex, so in this case it's 8. And let's get some additional points. So I'll choose x equals 3. I'll go x equals 3. Let's copy down the original problem again. And let's substitute 3 in for x. So negative 3 times 3 squared plus 6 times 3 plus 5. Order of operations, this is not negative 9 times negative 9 is 81. This is 3 squared first. So negative 3 times 9 plus 6 times 3 plus 5. It's going to be negative 27 plus 18 plus 5. That gives me negative 4. So that means I have the additional point 3, negative 4. So I'll graph that. That is 2 units to the right of the axis of symmetry. So let's go 2 to the left of the axis of symmetry and plot a point, and let's label that in the table. So I chose -1, -4, and I did 3, -4. Those are my additional points. And don't forget to connect your points. All right, so that is the end of that lesson. That was graphing quadratics in standard form.